All right, welcome back. This is EENG 460, and we're going to talk about Lab 7 today, which uses floating point stuff on the MIPS. And the idea behind this is you're just going to prompt for a floating point Fahrenheit temperature, and then you're going to print out a centigrade. Let's go ahead and just run it first to kind of show you what I'm expecting. It's already loaded, so I'll just click play right here. And let's see, the first thing, it prompts you for a Fahrenheit temperature, so why don't we enter 212, 212. And if I hit enter, it echoes back that you entered 212, and then the centigrade temperature is 100. All right. Now let's run it again, but instead of doing file reinitialize, let's just go to our program counter, right click, change that guy to 0040 to quad 0. And then I'll just run it again by clicking the play button, and there I go. It just runs again. So this time let's enter 100 for Fahrenheit. And what did we get? 37. All right, that sounds about right. Okay, and let's come over to here. Let's run it again. And let's put the program counter back to where our program starts and click play. Run it again. This time, let's see, what would be a good one? Well, 32 Fahrenheit. Let's see if that gives me 0 centigrade. And it does, gives me 0 centigrade. And let's try 0 Fahrenheit, just to kind of round out the test data. Right click, change register, new program counter 0040 quad 0. And if I run this, let's do a Fahrenheit of about 0, which is darn close to what it's been outside lately. And then that should probably give me a negative, right? And a negative 17 degrees centigrade. All right, so there we go. We basically prompt, we read in some float, we do some floating point arithmetic, because to convert, what do? You basically multiply by 5/9 and subtract 32 or something like that. Can't remember exactly, but it involves some floating point stuff. So let's take a look at the program to see how this happens. And here's the program. Okay. I've got my comments up here. Okay. I've got a data segment, and of course all this stuff is just strings. All the header information, normal termination. This is where I prompt them to enter a floating point, and then this is where I echo back what they entered, and that's going to be in Fahrenheit, and then this is where I print out what the centigrade value was. And down here I'm going to need some constants, and I want them to be of type float, which corresponds to IEEE 754, and there it takes 32 bits because they're float. Double would take 64. Okay, so I've got one constant, 5.0, 9.0, and 32, and I'm going to use these constants when I convert, because I'm going to take 5 divided by 9, which is what I'm going to multiply one of the temperatures by, and then I am going to subtract 32. Okay, so I need to get those guys into memory and then do some arithmetic. Okay, well, let's look at the main procedure. Okay. Once again, I have my usual no-op statements, so if my program crashes, I can kind of look at the Qt-SPIM and figure out which routine it crashed in, where to set the breakpoint, and start debugging techniques. Now this guy right here, I'm not sure what in the heck that's for. Let's get rid of that. Yeah, so I'll file save that guy. We don't need that. Well, the first thing is lab header. Well, I think by now in the course everybody's an expert at doing a lab header, right? What does lab header do? Well, it just load immediate v04, load address of a string, and then syscall. And it's the exact same thing. I do course name, carriage return, number, carriage return, student name, carriage return, date, carriage return, and then I return 0 and v0 and v1. Right? So there's no new surprises on that. And then here I have some information. I'm not using any of my input parameters, and I'm returning 0 in my return registers. Okay? So back up in main, that's lab header. All right, that's nothing new. What's new is store constants. I got to get those constants, which I talked about up here, 5, 9, and 32, out into memory somewhere so I can use them. So let's go look at store constants. The thing to note is I'm not passing any parameters, I'm not loading up any A registers, and I'm not pulling anything out of this procedure. So it takes no input arguments and it returns no values. All right, let's scroll down and look for store constants. Here is store constants. Okay. Store some constants out by the global pointer. Okay, once again, I'm not using any input parameters and I'm not returning anything. But what you've got here is you've got this L.S. Now that's a pseudo command, and what it basically stands for is load single precision. And it goes up to my data segment, finds the label constant 5, which is associated with the number 5.0, and it moves it into a floating point register, and in this particular case I'm using F4. Okay, remember what constant 5 was? Constant 5 was 5.0. Constant 5. That's why I called it that name. Okay. So what I did is I just read that guy into F4 with the L.S command. I just put that 5.0 into F4, and it's being stored in F4 according to IEEE 75 formats. But I need to convert that to an integer register, and I can't move a floating point register to an integer register straight away. I have to use this command right here, mfc1. Okay? And what that says, mfc1, it says move from coprocessor 1. So it's in a floating point coprocessor register. I need to move it to an integer. So move from coprocessor 1. Where am I going to move it? I'm going to put it into T4. So I'm moving it from a floating point register to an integer register. Okay? Now, in that integer register, it's still going to be an IEEE 75 format, but if we actually printed it out and worked with it, it would be interpreted as an integer. All right, well, now that I've got those 32 bits in there, what I need to do is I need to write them out. Because they're now in an integer format, I can use my store word command to write it out past the global pointer. So I'm going to write it out, T4, which is the integer register holding a floating point 5.0 according to IEEE 754, and I'm going to write it out 0 bytes past the global pointer. Okay. Then I just repeat the process. I take my constant 9.0, I load it into F4, and then I move from coprocessor, which takes F4, moves it into T4, and then I just use my old friend store word that writes it out 4 bytes past the global pointer. And then I pick up 32. I move it into F4, I move from coprocessor to T4, and then I store T4 out 8 bytes past the global pointer. So I'm storing 5, 9, and 32 at 0, 4, and 8 bytes past the global pointer. And there you go. So now I've got those guys into memory, and I know that they are offset from the global pointer by 0, 4, and 8 bytes respectively. Okay. Now notice what I do. I don't bring anything back, and I don't pass anything out, bring anything back. Now on the next one, I prompt them to enter an F. Okay, I prompt them to enter an F. And then the float, that's going to be the Fahrenheit temperature, and then I am going to return that in V0 like you always do, but I'm going to put it into S0. But that's kind of interesting. I'm prompting for a floating point, but I'm returning it in an integer register, and then I'm storing it in an integer register. All right, well, let's go take a look at prompt for F. Prompt for F. Where is that guy? There it is, prompt for F. This procedure prompts and reads in Fahrenheit temperature. Okay, I'm not using any input parameters, but I am going to return this Fahrenheit temperature in V0. Okay. So what do? Well, we print out a string. It says, please enter Fahrenheit temperature. Then we go and use the floating point mechanism to read, or the syscall mechanism to read a floating point value from the console. And the way you do that is you load immediate V06. Because now V0 takes on different values. You know, we've used 1, 4, and 5 to read and write integers and strings. Now we're going to use 6 to read an integer, read a floating point, but that floating point gets put into F0 automatically. Okay? Read into F0. So then I call syscall, and that's going to read in my floating point. Okay? Then I come down here and I just print out another string to say this is what you entered. And then what I have to do is when you print from F12. You read into F0, you print from F12. So now I've got to move F0 to F12. Well, I do that with the move.s command, move single precision. So now it's in F12. I can set up V0 with 2, and I can call syscall, and that prints out that floating point number. All right? Now, let's see, do I still have my console window up? Yeah, so what we're talking about now is we just printed out that floating point number right here. We read it in, and then we printed it out. And this is where we'd print it out. Then I print out 2 carriage returns. But the number that I want is currently in F0. It was read into F0, but it's also in F12 because I needed to put it there to print it. So I've got my number that I want to get back to main in both F0 and F12. Well, how do I do that? Once again, move from coprocessor. So I got to take F0 or F12 and move from coprocessor to an integer register. And then I'm not using V1, so I set that to 0. So the Fahrenheit is now in V0, floating point IEEE 754, but an integer register, and then I jump return. Okay, so let's go back to main and see what happens. We got that floating point Fahrenheit coming back to us in V0. All right, so I take what's in V0 and I move it to S0, and that's what I'm saying up here. S0 holds the Fahrenheit temperature. Okay, and let's see, at that point, see, we're getting kind of long here. What did we do? We just prompted for S. Yeah, I'm going to stop this guy, and then I'll start that next time. All right. See you later.